Well, this video won't be long, I hope, and I think that you guessed the reason of enriching the data, and if you have the imbalanced dataset problem, the enriching the data is the best possible solution. The word possible is not a good word to add to the title, but what I mean is if it's possible to enrich if it's possible to enrich the data, this is the best solution, or this is the first solution that you can do. Even if you try to augment the data, before going to the augmentation, if you add more samples for small classes, this will be a good, because this will increase the variance, and deep learning, machine learning algorithms are uh, really they are fell in love with variance and the big data. Actually, they love the variance, and the variance comes with mostly comes with big data. And this is the scene from our scikit-learn example. We created an artificial data that has a small number of samples for two categories and large number of samples for one category. And the thing that I want to indicate is we could try to increase the data that is for that is for uh, categories that has small number of samples. And actually I always indicate that we should increase the data for the categories that has a small data, but I didn't say anything about the large category. Well, the reason is if in machine learning or in deep learning you can do random undersampling like that, and in random undersampling you should have let's say that we are working on convolutional neural network that has 300 images for one category and 1000 images for one category. If you apply undersampling to it, you will have 300 images per cat and 300 images per dog in our example, and this won't be a good thing, because you you decrease the variance of the data from one category, and actually you have a bigger variance. Let's say that this is the cat data, and you have a bigger variance in your cat data, and a small variance in dog data. And when you undersample it, you decrease the variance of it. So this is not a good thing if you have a little data, or if you have a little if you have a one category that has a little sample or small number of sample. But the reason of enriching the data is variance, and actually the reason for not getting a good accuracy in this application, let's we get a good accuracy during training, but in our application, we when we test the minority classes, we get a very bad results. So the reason is they haven't got a good variance on the data, and you can do random oversampling. Let's get back to this image. You can do random oversampling, but if you have thousands of images per class, this can be a good thing. Maybe you try to not to deal with RAM consuming problems during training. This can be a good. Maybe you can get a good accuracy with smaller data, but uh, in a smaller time. So the undersampling is good for these problems. But if you have a very small data, let's see our problem. We have where is it? Well, when in our data, in our scikit-learn example, we have less data in one category, and probably it has uh, 20 samples per class. And if you apply random oversampling, it means that if you if you use random undersampling and you undersample your category that has large sample, and if you equalize your number of data, number of data sample, and if you get 20 samples per class, this won't be a good thing because you will have less variance when it's compared to the previous application, and random undersampling is not the thing that you want to do in convolutional networks if you have very little data. And let's go back to uh, imbalanced data examples. So the reason to get a better accuracy is you have less variance because you have little data in your minority classes. So actually we need to increase our data with some way, and we will do it by enriching the data. And if it's possible, this is the best solution. Or if it's possible to enrich the data, this is the first thing that you should do. After that, you can do data augmentation. Because if you have the data and if it's possible to get the data, but if you still uh, has if you still have small data, even if you enrich it, let's say that this is the same example, I know that, but if you are working on a medical laboratory and you can observe only 3 samples per day and you want to test deep learning, and if you can add samples to your minority classes, or if you can add samples to your classes, this is a good thing. And first thing that you should do is enriching the data. And if it is not a if it's not possible to get a good accuracy, you can do image augmentation. But the enriching the data increases the variance. In a nutshell, we have two important results with this in this video. Enriching the data is the best possible solution, and if it's not enough, if our data is not enough to get a good accuracy, the first thing that we should apply is enriching the data. And if we don't have a possibility to enrich the data, or if we reach the limit of enriching the data, we can apply the data augmentation after enriching the data.